Hi everyone. This week we look at multidimensional arrays in Java. So last week we saw single dimensional arrays, which may be referred to as lists. The most common type of a multidimensional array is the two-dimensional array, which may be referred to as a table. So whenever you have tabular data that needs to be represented in a computer program, one of the really good tools or data structures that you can use is a two-dimensional array, and the information is stored in what looks like a table. So the table is going to have a number of rows and a number of columns. We got two dimensions, the rows and the columns, and then each individual element can be referred to with the help of its two indices. The first index identifies the row and the second index identifies the column. So let's start with the declarations and the creation of two-dimensional arrays. The way to declare a two-dimensional array in Java is with the help of the data type of the items that are about to be stored in that array, along with two sets of brackets. Okay, so the two sets of brackets tell Java that you are creating a two-dimensional array. And then of course you pick a good identifier for the name of your array, a valid one. In the next step here, that's usually combined with the first one, you see how the memory gets reserved for your array. So ref var is the name of our array in this case, and the statement that allows you to start using the array is you use new, the keyword new, along with whatever the data type of your array is, along with the number of rows and columns that specify the dimensions of your array. In this case it's 10 by 10, which means this particular table or this particular two-dimensional array is going to have 10 rows and 10 columns. And as we already know from last week, that means our indices are going to go from 0 to 9 for the rows and 0 to 9 for the columns. Down here you can see how you can combine the declaration and the creation in a single statement. So we tell Java we need a new array and here's what its size is supposed to be. For legacy purposes, this kind of syntax still exists, just like with the single dimensional arrays, but it's generally discouraged. You're discouraged from using it. The new way of setting aside memory for arrays is by using the square brackets after the data type rather than the name of the array. And on this next slide again we have a quick example of an array declaration and creation in this first line here, along with an initialization where we set the values for all the individual data cells of our table. So we have this time a nested for loop. A single for loop is not going to do. It's going to help us set up a single dimensional array, but if we're talking about a 2D array, we're going to need to always have a nested for loop so we can go through all the rows and all the columns one by one. As we do, we identify the individual data cells with the help of their indices. We use the loop variables I and j for that purpose, and we set them up carefully so they go from 0 to length minus 1. That's the number of items we have per row, and then j is the number of columns. It's going to go from 0 to length minus 1 for each individual row. What are we initializing the data cells for this particular table? Well, you can tell from here that it's an integer going from 0 to 999. That's how the math random function works. One more example down here, declaring a double array without initializing it, just the declaration statement. You do double with the two sets of square brackets and then a name for your array. Visually, here's how arrays get stored in memory. Okay, well, in the first example, we've got a 5 by 5 matrix or table, and if we need to access, let's say, this one element right here, it's the element located in the third row, second column. So to identify the third row, second column, you're going to use indices 2 and 1. Why? Because indexing starts at 0. So if you are setting the value of this one element to 7, you're going to need to use matrix 2 1 equals 7. In the third example, you see an array that has 4 rows and 3 columns, so it's a 4 by 3 array being initialized the moment it's declared. This is called a shorthand notation for the initialization of an array. And here's a description of how shorthand works. You declare, create, and initialize the array in one single step. Programmers like this approach. It's considered to be a good programming practice, but it requires that you know the values of all of your elements at the time you're doing this. With the two-dimensional arrays, each individual row represents a single-dimensional array. So normally your 2D arrays are going to have the same number of columns, so they're going to be rectangular in shape. However, that's this is not mandatory, so the length of each row can vary, and we will see in just a moment how that can work. But right now we're looking at a rectangular array that's made up of 3 rows and 4 columns. If you want to extract the length of each row, you do so with the length attributes. So you reference the first row of your array with, in this case, x0, and then dot length, and that will return, in this case, 4, because we got 4 columns. The size of your multi-dimensional arrays, you can quickly figure that out. If they're rectangular in shape, you simply multiply the dimensions. So if you declare a 2D array with int 10, 20, you got 10 rows and 20 columns, all you got to do is just multiply 10 by 20 and you'll have the number of cells in your table. If you're talking about a 3-dimensional array, likewise, if you've got tables that are rectangular in size, then all you have to do is just multiply the dimensions, 5 by 10 by 20, and in this case you'll end up with 1000 elements. So these are the standard kinds of arrays. You can do this really easily. Ragged arrays or jagged arrays, those two terms, they are used nowadays to identify the same thing. Ragged or jagged are arrays that may have a different number of cells on each row. In other words, they're not rectangular in shape. In this case here, the example, we got 5 elements on the first row, we got 4 on the second, 3 on the third, 2 on the fourth, and 1 on the fifth. This is perfectly legal in Java, and it's called a ragged or jagged array. Okay, if you see the term C-style arrays, it's just another name for rectangular arrays. And like I said in Java, you are allowed to have ragged arrays. Now let's see how we can process two-dimensional arrays. The two-dimensional arrays are the most popular multi-dimensional arrays. The other type of multi-dimensional array that you probably find good use for is the three-dimensional array. You will probably never go beyond 3 dimensions. 4 or more dimensions are pretty impractical. There are no problems in real life that lend themselves nicely to being solved using arrays with that many dimensions. And that is the reason why when we talk about multi-dimensional arrays, we're really referring to 2 or 3-dimensional arrays. So initializing the arrays with input. You set up your nested for loop, and in there you invite the user to enter, in this case, integers. You just have to be careful in making sure that you use row, that you know you're referencing the row in the first dimension and the column in the second. Okay, and that's precisely what they've done here. They go row by row, and then within each individual row they initialize the cells, which means all the columns. Initializing with random values, you can see here that my nested for loop is identical to the one from the previous example, except we're not inviting the user to enter values. Instead, we're simply assigning random integers to the individual cells. This can help you whenever you need to work with a two-dimensional array that has been initialized to something, to values that are not zeros. And in this case, it's going to be integers that go from 0 to 99 inclusive. Printing the arrays, again, going row by row and then column by column within each row. You print all the cells on one row, then you print the new line characters, so you move on down to the next row, then you print the next row, again move on down one row, print the next one, and keep going like this. Summing up all the elements, again just be careful about the way you use those indices. The first index is used to identify the row, the second index is used to identify the column. And since we're summing them up, our accumulator needs to be initialized to 0. Summing the elements by column. So in this case, we don't want to sum up all the elements of the array, just the elements of an individual column. Well, you can set up your for loops so that you visit all elements of the array within, let me make sure I say this correctly. So within each column, we set up an accumulator that starts at 0, and then we go row by row, adding all the elements for that column. When we're done with this, we print out the sum for the column and we move on to the next column. Again, we're really just playing with the dimensions here. It's not a big deal. You can traverse the array row by row or column by column. The tricky part is remembering to always reference the row first and the column second. Random shuffling is something we did with single dimensional arrays as well. What we're doing here is we are going through each and every element of our two-dimensional array. We are also picking two random indices, I1 and J1, and they help us identify a random element within the table. We take that random element and we swap it with our current element. Once you're done with this with this nested for loop, you would have shuffled randomly the values of your two-dimensional array. Okay. Passing two-dimensional arrays to methods. We already know we can pass arrays as arguments to methods. What you're seeing here is two different examples. In the first one, you can see the definition of a Boolean method called isValid that is supposed to take a two-dimensional array as an argument. So within the parentheses, you're going to see the data type along with the two sets of square brackets, and then a name for the array that's going to be used within this function here. And you can do whatever you need to do with it. For example, you can check whether this array is valid and then return true if that's what the method is supposed to do. In the second example, it's called getArray. It doesn't take any arguments. In here you declare a new two-dimensional array of integers. You set aside the necessary memory, and then, for example, you can generate random values for the elements, and you return that as the result. As I mentioned earlier, in Java you can use dimensions that are higher than 2. All of your methods and all of your algorithms are going to work in much the same way. So n-dimensional data structures are legal in Java for any integer n. And the way you declare your array variables and create them is simply generalized from what you just saw with the two-dimensional arrays. But that said, keep in mind that going beyond 3 is really never necessary. There are no real-world problems that can be solved with such arrays efficiently. So whenever we talk about multidimensional arrays, we are referring to 2 and 3 dimensions. In my final 2 slides here, I got an example of a three-dimensional array, so you can visualize what it looks like. Please do note that there is an error here in the numbers. The 6 and the 5 are swapped. I'm sorry, I can't fix it because this is an image. But from what I can see up here, scores is a three-dimensional array that has been declared and initialized in this one statement, and the 3 dimensions represent the following things. The first dimension is the number of tables or the number of arrays within these three-dimensional arrays. And then the second and third are again rows and columns. Okay, so second and third dimension are rows and columns for each table or for each matrix, and then the first dimension is how many matrices or how many tables you're representing. This is visually what this looks like. So rows and columns, assuming that this is a three-dimensional array that has, you can tell it's a 3 by 3 by 3. So you got 3 tables and each one has 3 rows and 3 columns. If we back up here a slide, we got 1, 2, 3, 4, 5 tables. So that should be our first value here. Each one has 6 rows and 2 columns. So 6 rows and 2 columns. And in the example we're seeing, we could be using this, for example, to store the scores of individual students, where the first dimension is used to identify the student, the second one to identify the exam, and the third one is an individual score for an individual problem within that exam. It can be anything you want. The purpose of this was just to illustrate how to declare and initialize a three-dimensional array. One last time, please do note that there is an error in these two numbers. They should be swapped. We go 5, 6, 2 if we are to follow the values that are stored up here. Okay, that wraps up our discussion on 2- and 3-dimensional arrays in Java. Thank you very much for watching.